Okay, ladies and gentlemen, I'm going over stoichiometry problem number 1 from our chemistry packet. You should, I recommend, in fact, I'm just short of demanding, you have your double mole conversion chart ready to go. So, in question number 1, based on the following balanced equation, so we've got the balanced equation, nitrogen, 3 hydrogens, change into 2 molecules of ammonia. So when you go to set this up, we're starting, it says if 15 grams of nitrogen react, that's our given. So I recommend at this point, over here, 14 grams, thank you, of N2. Now remember, you got to make sure it's N2. It's not just plain old N, because it's nitrogen gas, so you want to make sure you get that set up. That'll be important for the molar mass. And it says how many grams of ammonia, NH3, are produced. So we're looking for this. In fact, over here right now, I'm going to put blank, and it's grams of NH3 produced, just to make sure I don't mess up, NH3. So we're coming over here, we want blank grams of NH3. So looking at this chart right now, we're starting over here with 14 grams. We're going to have to convert this into moles by multiplying it by the molar mass, the grams per mole. Then that'll give us moles. Then we're going to set up the molar ratio. So we'll get moles of B, which in this case it's ammonia, divided by moles of A. That's going to give us moles of ammonia. Then we need to convert back into grams by, let's see, when we're going this direction, going to it, okay, going to it. Oh, we use grams per mole. I used the wrong arrow previously. So, first off, we always put what's given. What's given in this problem? 14 grams of N2. Don't be chintzy. Don't just put 14 grams. You have to put what you're given. And now we want to go to, we need to go to the mole. So actually I made a mistake before. We're going this way. We need to do moles per gram. So I'm going to put in 1 mole of N2. How many grams is 1 mole of N2? 28. You look on your periodic table, you find out that nitrogen is 14, so 2 of those will be 28 grams. Oh, I already have the grams. Grams of N2. So now at this point, grams of nitrogen cancel out. On our roadmap, we're right here at moles. We want to now do the mole-mole ratio. So we're now going, and we wanted moles of ammonia. And on our balanced equation, how many moles of ammonia do we have? We've got 2 moles of ammonia, 2 mole NH3. And how many moles of nitrogen do we have in the balanced equation?
1.
Just 1. And if it helps you out to put a coefficient 1 in front of it, go for it. There's nothing wrong with doing that. On the test, you'll have your own, you can write on the test paper, so you won't have to be just, like in the first few tests. 1 mole of NH3. So now, oh, wait a minute, my mistake. That was N2, wasn't it?
Yeah.
Now, at this point, we've converted into moles of, this case, NH3. Now we need to come back to grams, because that's what we're looking for. So when we go down to grams for moles, we want to do grams per mole, the regular molar ratio. So let's see, and we said, okay, NH3, what is its molar weight? Now you won't have your cheat sheet to use. See, nitrogen is 14, hydrogens are how much? Each hydrogen is 1, there's 3 of them. So what's 14 plus 3?
17.
So the molar mass is going to be 17 grams of NH3 in 1 mole of NH3. Now the moles cancel out, and let's see if we can do some dividing here before we start. Oh, look over here, how convenient. How many times does 14 go into 28? 2. So we can put a 2 there and a 2 up here. Oh, and look at here. This 2 cancels with this 2. 1 to 1. So are we at now 2 times 1 times 1 times 17 is what?
14 should be 1.
Yeah, the 14
Wait a minute.
should go to 1.
Oh, thank you. Oh, sorry about that, everybody. Oh, see, now there's a dumb mistake you can make. And no, you get the problem wrong, and you knew how to do it. You just weren't thinking. So, that's thank you for catching that. So 1 times 1 times 1 times 17 is 17 divided by 1 times 1 times 1. That's just 1. And then We ended with grams of NH3. Question about this one before we work part B. Now, working part B, you've got a choice now. You can come back to part B and start with what was given over here. You can make your given, well, our given is 14 grams of, oh, that's the same as up here. Or you can start from how many grams of NH3 we have. Because it'll probably be easier if you start with 17 grams of NH3 because you're already on, you're already on this side of the equation. You're already on the NH3 side. So what are we going to do? We're going to start with 17, or are we going to start with just what we were given, 14 grams? We're going to start with 14 grams. So again, we start with 14 grams of N2, and it's going to be started off, it's going to be just like the previous problem. Oh, but this problem this time, we want to see how many molecules of ammonia. So instead of grams of ammonia, we are now looking for molecules of ammonia. So that's what we're looking for. The roadmap, we're going, instead of back to grams, we're going over here. So it's going to be almost identical to what we did before, but then we're just converting to molecules. So grams to moles, we will multiply it by moles divided by grams. So 1 mole of N2 is how many grams?
28. Mr. Kenny, when would we ever go from moles B to moles A? Moles A is what you get, correct?
The question asked was, when are we ever going to go from moles B to moles A? It may not in the question. You know, if you get a multi-part question, they might say, now that you know how many grams of whatever you're producing, it might ask you to go back and figure what the volume of your original was. If it doesn't ask you to go back, you don't have to do it. I think one of these problems, it actually kind of does that. So back over here, now what we're doing is, since we're looking for molecules of NH3, so let's see, we need to look at our molar ratios now. And so we've got, we want to do B over A. And B is going to be NH3 because ammonia. So we have 2 molecules of NH3. Is that correct so far?
Yeah.
And we have 1 molecule, excuse me, 1 mole of N2. So see, up to now, it's the same as what we did up there. But now, instead of turning this into grams, now we want to go to particles. We need to, see, since we're going this way, we're going to multiply it by 6.02 times 10 to the 23 particles in a mole. So 6.02 times 10 to the 23. You're probably on the test. You're probably okay just to put 6. Molecules. Make sure you label these. Molecules, and it's NH3 in 1 mole of NH3. Now, does that make sense? Does 1 mole of NH3 have that many molecules?
Yes.
Yes, it does. Okay, so the moles of NH3 will cancel out. And now, once again, we're going to cancel this to 1. This becomes 2. Is that correct?
Yep.
Now, does this 2 and this 2 cancel out?
No.
Yeah, it does. That 2 can cancel with that 2. And now what we've got is, oh my goodness, is it just 6.02 times 10 to the 23 molecules? Now, what you might realize too, here's a way that we can make this shorter. When you first set this up, when you take a look at this, you find out that 14 grams of nitrogen, I'll just stop there, I don't want to get you confused. Now part C, can I go on? Question there? Now in this problem, let's see, we're starting with this many molecules of nitrogen. Now, if you have that many molecules of nitrogen, and that's nitrogen gas, how many moles of nitrogen do you have? So you can start this conversion problem with 6.02 times 10 to the 23, or if you look at this and say, well, that many molecules of nitrogen is 1 mole, you can start it right there and you don't have to do a conversion step. How many molecules of hydrogen gas will react? So we're looking for molecules of hydrogen gas. Okay, so that's what we're looking for. Do I need to start with 6.02 times 10 to the 23, or can we all agree that that's going to be 1 mole of nitrogen?
What's this one here?
You know what? Tell you what. 0.02 times 10 to the 23 molecules. Maybe I better not miss a step here. N2. And there are 6.02 times 10 to the 23 molecules of N2 in 1 mole of N2. Oh, I didn't go to our chart. So we're starting with molecules of nitrogen. So on our roadmap, here's where we're at. We're at this part right here, and we're looking for molecules of hydrogen gas. Make sure I did. Okay, so we want to end up over here with molecules of H2. So we're going to be going up here to moles, mole conversion, and then down over to here. And we've already done this first step. We've converted to moles. Now we set up the molar ratio. We're going to B, so moles of B. Now, hydrogen gas is what we're looking for. So how many moles of hydrogen gas do we have in this balanced equation?
3.
We have 3 up there. So 3 moles of H2. And then let's see, we're coming from moles of nitrogen gas. So how many moles of nitrogen gas? 1. Moles of N2 cancel. We can go ahead and cancel out 6.02 times 10 to 20 molecules there, and right over there. That just becomes 1 and 1. We've got moles of hydrogen. We're looking for molecules. So in our conversion chart, in our road chart, we're here at moles. We need to go to particles. And when you go to particles, you multiply by 6.02 times 10 to the 23. So 6.02 times 10 to the 23 molecules in 1 mole of H2. Now these will cancel out. And we're left with 1 times 3 times 6. So what's 3 times 6? 18. If you want to be real precise, we could do 3 times 2 would be 06. Okay, we don't have to be that accurate necessarily. But now, don't forget the times 10 to the 23.
So you
Times.
don't have to mess with the times 10 to the 23.
Well, you don't have to necessarily mess with it, but you got to make sure in your final problem that you do put the times 10 to the 23 there. Now, make sure down here, 1 times 1 times 1. Now, we got to convert this into proper scientific notation. Let me zoom in so you can see that. So if we change this to 1.806, okay, so if I make this number smaller to make it scientific notation, how do I balance that with an exponent? Do I make it bigger or smaller?
Bigger.
It has to go bigger. If I'm making this number smaller to scientific notation, you make this one bigger.
Why
So
don't you make it smaller?
I don't understand. Do we have to make it like that, or can we just put 18.06?
if you come out with 18.06, chances are on the test we're going to have any big answers like this in scientific notation. So you need to know how to convert that to scientific notation.
Wait, how do you convert it? Is it the same answer, just 10 times
No,
the
we just moved the decimal place.
We just moved the decimal. In scientific notation, they always have one number, then the decimal point, and then the rest. It's okay. That's scientific notation. So when you do that, if you move this decimal to make the number smaller, like we just did, 18 to 1.8, then we got to balance that by making this bigger. Because we're making this 10 times smaller, so we make this one 10 times bigger to give it equality. Have a question?
So what numbers does that like count for? Like if it's only 10, does it have to be? Like if it was 9, you don't have to put 0.9, do you?
Let me get that question separately, okay? So now, the last question on here. Can I go on to D? Okay. Now again, if you've got these, you keep working on the rest to get the practice going. You can just make sure we did it right. If 1.5 moles of nitrogen react, how many moles of ammonia are produced? Okay, now I'm going to show you first the quick and simple way to do this. Let's take a look at our molar ratios up here. Let me clean this up here so we don't have anything. zoom out so we can. You could do this in just one step without having to do the full conversion. So, how many moles of nitrogen do we have in the balanced equation? Ladies and gentlemen, if you're like you to be quiet, please, because some people are listening. How many moles of ammonia do we have in the balanced equation? Excuse me, we're looking at the balanced equation. How many moles of NH3? 2 moles. So we have a 1:2 ratio of nitrogen to ammonia. Is that correct? So if we start off with 1.5 moles of nitrogen, we should have twice the amount of ammonia moles. Is that correct? So what's twice 1.5? So the answer will end up being 3 moles of ammonia, because when we look at the molar ratio, for every one every mole of nitrogen, we have 2 moles of ammonia. So we have, given this 1.5, we just multiply whatever moles we have here by 2, and that'll tell us the moles of ammonia.
So if it asks you a question like that, that's how you just
Okay,
look at
that's,
the video.
if you can make that step, that's how you do it. Now, if you're not used to making that step, we'll use the road map. We're given 1.5 moles of ammonia. So I'm going to make this ammonia and H3, and we're starting right here at moles. And how many moles? We have 1.5. And we're looking for moles of ammonia. So, this is pretty nice. It's just going to be one conversion step. We don't have to do a whole bunch because we're looking for, wait a minute, did I do that? Did I set that up wrong? I goofed that up, didn't I? We had 1.5 moles of nitrogen, sorry. This was N2, 1.5 moles, and we're looking for NH3, that many moles. So when we set this up, we'd put 1.5. So if you don't understand how to do this with the ratio method, we just do the moles of N2. Let me get this out of the way so it's not distracting us now. And now we're just setting up the molar ratio. And we're going to over here, so we need moles of NH3. We have 2 moles of NH3. And we have 1 mole of N2 in the balanced equation. These just cancel out. And we end up with 1.5 times 2, which will equal what? 3 moles of NH3. So we got the same answer we did when we were looking at the molar ratio, but if you can't do that step, if you're not used to looking at the molar ratios, then you can set up and do the stoichiometry there. Okay, I'm going to be quiet for a moment, and I want you to work on, I'm going to give you 2 minutes to work on 2. If you're done with 2, get working on 3 and 4. I'm not going to go through the entire step-by-step in a few minutes, but we'll go over the answers. So, say goodbye, everybody.